Okay, now we're going to look at some problems for Chapter 2. So looking at this, the U.S. population is estimated to be 332 million. The zeros to the right, in this case, they're ambiguous, so we're not really sure. This one has 3 sig figs, and we can write it as 3.32 times 10 to the 8th people to 3 sig figs. So the radius of the carbon atom has a bunch of zeros. Zeros to the left are not significant, so we can count them over, and then we can have, and those zeros to the right are, so that has 2 sig figs and have 7.0 times 10 to the minus 10 meters. So looking at measurements here for the bathroom scale, the measurements are between 140 and 160, and then counting the graduations over, it's going to be it's 140 between 147 and 146, and it's closer. I'm sorry, 147 to 148, and it's closer to 148. So you have to put it a little bit closer, like 147.7, and yeah, so then it's plus or minus, a tenth of the graduation after that. So that's how you would read and measure that that scale. How many sig figs in each number? So zeros to the left are not significant, so A has 2 sig figs. Zeros to the right are significant, so B has 4. C has 4, because each number is significant. D, there's 3 numbers, then the exponent. So the 2.97, those are 3 sig figs. E, this is an exact number that has infinite sig figs. F, the zeros to the right are significant, so that has 5 sig figs. And G, that's ambiguous. You're not really sure how many sig figs it has. It might be 1, might be 0. It's hard to say. So there's that. Let's do for multiplication division. So you do the operations, do it from left to right, and then you bring it to the lowest number of sig figs. So for this operation, then you run it over, and you put the answer to 2 sig figs. And for B, throw in your calculator and then do it to 3 sig figs, because the 0.920 is 3 sig figs. And do that, and then put that for each of those. So just like so. Okay, addition, subtraction. So you only know this to the lowest amount, so perform the operation in your calculator. But for A, you can only know it to the 10th place, and B, you can only know it to the 100th place, because that's the lowest number there. So when you do that, you take these and then you round it to the number that's there, to the one that you're pretty sure you know at the end. So what about multiple steps? So for this one, for part A, you have to do the parentheses operation first. The order operations are parentheses, then exponents and or logarithms, then multiplication, division, then addition, subtraction, and then each of these left to right. So you do the middle part first for A, and that's going to bring it down to 2 sig figs. And then you do the multiplication left to right, and then you're going to bring it. It looks like it's going to be 2 sig figs. I'll look at the next page. For B, you don't really need to do the parentheses in there, because by order of operations you don't need it, but go ahead and do it. That multiplication term you have to bring down to 2 sig figs, whatever that is, and then we have to look at the rules of subtraction to see where it fits. So for A, yeah, you bring it down to 2 sig figs with the stuff in the parentheses. So the answer, then you bring the 2 sig figs, and so for part B, the operation in the parentheses, you only know it to 2 sig figs. So when you subtract it, you only know it to the 10th place. So that one's a little tricky. I must admit, that one's a little tricky, so you have to pay attention to that one. That one's a hard one. Unit conversion converts 7.8 kilometers a mile, and again, you're using dimensional analysis. So the idea is just, this one's a straight conversion though, just a one step, and you can convert it straight into that. And here are some common unit conversions. And the solution, 7 kilometers, and multiply it by 0.6214 miles per kilometer, and you can see the kilometers cancel, and we're left with an answer in miles. And then to 2 sig figs, bring it to 4.8. So does this make sense? Yeah, it sounds about right. It's like, a little bit more than half. and that's where we're at. It's kind of my mind. So how do we convert 825 millimeters? I'm sorry, 0.825 meters to millimeters. I even just in my mind I can already convert it. This is by using the power of tens with the scale. So we're gonna have to convert millimeters, and a millimeter is 10 to the minus 3 meters. And where do we get this? Get this by the prefix multiplier. I'm not going to show this for each and every problem. This is something you should have available to you, or at least understand, but most people have it available to you. And then we solve. So you just take it, and for me, I personally would do 1,000 millimeters per meter, but if you want to do division, that's fine too. And it's 825 millimeters, and so that one's a straight easy shot. So what about multiple step conversion problem? So for instance, creamy pasta sauce costs 0.75 liters of cream. You only measure in cups. How many cups should you use? So it's a little bit more than 3 cups. I already know that. So you can look up the different conversions, and because I know a cup is 240 milliliters, thereabouts. That's how I did it in my head already. So I know it's a little bit more than 3. But you have the quarts there, and then, of course, there's the common conversions. So more than one step, though. We start with, we know on the original on the left, 0.75 liters, and we're convert to quarts. Now we're going to convert to cups, and then we're given that, and then to 2 sig figs, 3.2 cups. So if it was me, I would just put 3, and then count a little bit extra and call it a day. Does that make sense? Okay, so what about running a track? A track measures 255 meters. To run 10 kilometers, how many laps does it take? So you have to go, if you want, you can just do, so 10 kilometers is 10,000 kilometers, and just take 10,000 divided by 255 and call it a day. But if you want to do the dimensional analysis, you can go through all of this. So a kilometer is 1,000 meters, and then divide by the number of laps. So it's 39.2 laps. So for 3 sig figs. Does that make sense? Okay. Solving using conversions in the numerator denominator. So prescription medication requires 11.5 milligram per kilogram body weight. Convert this number to grams per pound body weight for a 145 pound patient. Okay, so we have some of the conversions. So same old dimensional analysis, and then start off with 11.5 milligrams per kilogram. I would do, well, it's a milligram, like, well, 0.001000, 0.001 grams per milligram, and then kilogram to pounds, and you see everything cancels out, and you get 0.0052. How many sig figs we've got? 3. 0.00522 grams per pound. And then now we have a 145 pound person, and then go through, and then we get then the answer to 3 sig figs, 0.756 grams. So let's look at another one where you have to use units to a power. So a circle has an area of 2,659 square centimeters. What's the area in square meters? So we have to look at the conversion, but when you're doing squares, when you raise an exponent of things, you have to raise the whole thing to the exponent. So keep that in mind. I mean, there's 100 centimeters in a meter, but you have to make sure that you square both those terms because the unit's squared. So you put it in here, 2,659 square centimeters, and it's 0.01 meters per centimeter. I would probably put like 1 meter is 100 centimeters when I do this, but this way works too. And then you get the answer to the 4 sig figs, 0.2659 square meters. So does this make sense? Okay. So the average person crude oil consumption in the United States is 15,615 cubic decimeters. What is this value in cubic inches? So we're going to have to do conversion. And so start out with cubic decimeters to cubic meters, then to cubic centimeters, and then to cubic inches. So lots of steps here. So starting out with the cubic decimeters, so a decimeter is a tenth of a meter, so do that operation. Then a centimeter, do that operation, and then the inches. And you have to make sure that you have to keep on cubing in each step. And then doing so, you get 9, how many sig figs? Also, it's 5 sig figs. So then the answer then is in 5 sig figs for the cubic inches. A lot of oil. So calculating density, you're trying to, and this is, by the way, this is supposedly also how Archimedes got famous, that the king thought that the goldsmith skimped on his crown, and Archimedes was thinking about it, and apparently he was so excited that he was taking a bath, he ran to find the king without his clothes on to say, oh, we can do it by water displacement. So, good old tale from Archimedes. So the woman thought it's made of platinum. It seems a little light, and I can tell you platinum does feel very, very light. Has a mass of 5.84 grams, and then finding out that this place is 0.556 cubic centimeters or milliliters of water. How much is the ring made of platinum? So we want to find the density, and the density of platinum is 21.4. So let's figure out what the density is and then compare it to platinum. And then let's go ahead and do it. Density is mass per volume. We have the mass of volume, and we get 10.5 grams per cubic centimeters. And there is no way this is platinum. That's much too low. I sure hope that's not cadmium or something like that, because that would be very bad. So you can also use density as a conversion factor. So gasoline, an automobile gas tank, has a mass of 60 kilograms, a density of 0.752 grams per cubic centimeters. So what is its volume in cubic centimeters? So now we are given mass, and we're trying to find volume. So same idea, but we're given different units, so we have to change the kilograms and the grams, and then if we want volume, we need to make sure to divide by the density, so that the end term is a volume. So looking at the units, so let's do that. 60 kilograms, 1,000 grams per kilogram, divide by the density, and then we get 7.98 times 10 to the fourth cubic centimeters. So that's a lot. That's a lot of gasoline. But yeah, it makes sense. 160 kilograms. And being an American, I'm like, that's like 120, 130 pounds. So that makes sense. So let's look at some numerical problems. So a chemist needs 23.5 kilograms of ethanol for a reaction. What volume in liters of ethanol should the chemist use? Density of ethanol is 0.789 grams per cubic centimeter. So we're given kilograms, and so first thing we're going to do is convert to grams, and then with the density, we'll have to, and we're looking for volume, we'll have to divide by it again, and then we can get the volume and convert it to liters. So looking at this, so we start off with what we know on the left, and then again, setting this up, look at the starting with what you know, and then work your way over the units. So start off with a kilogram, convert to grams, then divide by the density, and then milliliter to cubic centimeter is the same, and then go to liters, and so 29.8 liters. So also, how dense are you? A 55.9 kilogram person displaces 57.2 liters of water. What's the density of the person in grams per cubic centimeter? So same idea. We just have to turn the mass in kilograms, and then the volume to cubic centimeters or milliliters, and then divide the two. So just focus on the units, and then get the mass, get the volume, and then divide that. So, and then you get very close to 1, so 0.977 grams per cubic centimeter. Yeah, so it makes sense. I mean, person's probably floating a little bit in the water then. So here's some things for scientific notation. If this is, well, the zeros are ambiguous, but 45 million would be then 4.5 times 10 to the 7 million. Sometimes they even put a decimal point here, or they normally wouldn't write 45 million and expect it to have that many sig figs. From this, you can kind of see it's 2 sig figs. So when you read things here, reading the volume of things, and that dip going down, that's called the meniscus, and you read at the bottom of the meniscus. So it's between 4 and 5, and that bigger line is 4.5. So it's close to 4.6, but it's a little less than 4.6. So you can kind of guess. I mean, just looking, I would say 4.58, but this says 4.57, but that makes sense. It's a plus or minus 0.1, so that's reasonable. So rounding, if you don't know how to round things, so if it's 5 or higher, you round up. If it's 4 or lower, you round down. So if you want for 6.442 to 2 sig figs, so that's going to round down, and then 6.456 that you round up because it's higher. The five, it's 5 or higher for that. So sig figs and multiplication division, we covered some of this before. So we have these 3 things divided, and you do it from left to right, and you have to bring it to the lowest number of sig figs. In this case, it's 2. So you have to keep that in mind, and when you have the answer, you have to round it to that number of sig figs. So addition and subtraction, we covered some of this before. You can only know it to the place that has the lowest, and for this one, it's the hundredths place. So when you do the operation, you then round it to the hundredths place. So what about for multiple? Do the parentheses first, and then do the multiplication. So the parentheses first, it's going to bring us down to 2 sig figs, and then when you do the multiplication, then you bring the answer to it's going to be 3 sig figs and 2 sig figs. Bring the answer to 2 sig figs. So convert 108 feet to meters. So use a bunch of them and start off with feet, convert to inches, then convert to meters. There's other ways you can do this. I don't have that memorized, but I knew 2.54 centimeters, so you can go that way and then convert centimeters to meters. That's the way I would have done it, but I mean this one is a cleaner. It skips a step if you do that, but it's just how I would solve it. So there's more than one way to solve these problems. So unit conversions with the numerator and denominator. So drug company listed dose drugs, 0.012 gram per pound of body weight. What's the dose in the drug in milligram per kilogram of body weight? So we've done a similar problem. So starting with this, what we know on the left, and then just start moving the units over. So changing grams to milligrams, changing pounds to kilograms, and then we're left with the right units there on the right. So how many square meters are in a square kilometer? So I mean, it's raising things to the power, right? So units are correct. It's a million. So you have to square with 1,000. So does that make sense? Yeah, it does make sense. It seems a little odd because we don't think in terms of exponents as much. So calculating density, mass of 23.4 grams displaces 5.7 milliliters. Well, the density is in grams per milliliter, so you just have to take the 23.4 and divide it by 5.7. So this is one you can do straight shot, and then bring it to the right sig figs. And density is a conversion factor. So we've had a few problems like this. 320 grams of liquid with density of 24 grams per milliliter. What is the volume? So again, do dimensional analysis. Start off with a given on the left, and then work your way over, converting the units, and you are left with then 0.38 liters. So kind of just moving left to right. And done for chapter 2.